Okay, so let me give you this thing that I'm going to call really bad graphing, which you could also think of as long-term behavior of polynomial functions. But that's a really boring name. Cool?
So you like extrapolate?
Yeah, so what I mean is basically, if you look at, what?
Nothing, it's just like, what's absolute zero? Like, you'd have to do this.
No, this is the other way.
Oh.
This is not zooming in on something, this is zooming out.
Okay.
So say I had f of x is, yeah, I want an x squared minus a whole bunch of x's. I don't even know what number that is, I just started drawing zeros.
It's a million.
Plus some other number that's really big.
Wow.
And all I want to know is, like, dude, if you throw this in your graphing calculator, one, it's going to explode, right? Like 10 to the 36th isn't a number that your graphing calculator does well with. Probably. I'm guessing it probably doesn't. But what I want to know is, like, what would happen if you zoomed out far enough on this thing? Like, this had a huge vertical shift, right?
Yeah.
And then some kind of weirdness, and it's a parabola. You all with me on that?
Yeah.
Like, looking at this junk here, you're like, parabola. Why is it a parabola?
Because it has an x squared.
Yeah, because it's got an x squared, right?
And that's all it needs.
Okay, so first things first, for really bad graphing, find the biggest power of x. Not the biggest number, not the biggest power in the equation, but the biggest power of x, right? That's going to control this shape. And the way it gives that shape is I think to myself, okay, I don't really care what's going on in the middle of this picture. I just want to know what happens when I go to either end.
You got it.
So if you go all the way to the right-hand end of this picture, you're going to plug in really, really big numbers for x, right?
Yeah.
Like frickin' gargantuan numbers.
Huge numbers.
So in the grand scheme of all the possible numbers, how does 10 to the 36th weigh up?
It's nothing.
It's basically 0 compared to infinity.
Yeah.
You guys all with me on that?
Mm-hmm.
How much does 100 million times a really huge number weigh up against that really huge number squared?
It's like so small.
It's like half.
It's
the square root of it.
Yeah, like once you're past 100 million, right?
Yeah.
It's like the square root of it,
Yeah.
or less.
Yeah.
You guys all see that?
Yeah.
Okay, so really this is the only thing that matters, this x squared.
Okay.
So which way is that going to point as I walk?
Up.
Like if I go way the heck out here,
It's going to point up.
that's going to go up,
Yeah.
right? So I'm going to get something like that on the tail.
Yeah.
You guys with me on this?
Yeah.
Okay. What about this side? Like minus infinity side.
You're going up.
It's going to go up as well.
I'm going to have a really big number that's negative that I'm squaring.
Yeah.
So that's going to be a,
Positive.
yeah, negative times a negative is going to give you a positive, right? So you're going to get a really big number and it's going to be positive. And then what happens in the middle?
Zero.
God only knows.
I don't know what happens.
Right? Like all sorts of stuff happens in the middle.
But it'll hit 0 at one point.
Specifically though, this is a parabola, right?
Yep.
You guys see that?
Yep.
So at most it could cross the x-axis
Once.
At least.
Sorry,
twice.
Yeah.
It's a parabola, right? You
Yeah.
cram it in the quadratic formula, you get maybe 2 answers out.
Twice, yeah.
At least.
You might get none. You might get 1. but you could get 2. You guys see that?
Yeah.
So my picture could look like this, or it could look like this, or it could look like this one that just tags down in the middle here someplace. You guys see that? And I don't really know where the y-axis is. That could be somewhere side to side. You guys with me on this? But at the very least, broadly, I know that this thing looks like a parabola.
Yep.
Let's call that. So if I had a similar thing, where instead of having x squared, I had f of x is minus 37x to the 5th, and then plus some x to the 4ths, plus some x cubed, plus some stuff, plus pi over e.
Okay.
Right?
It's not a parabola.
Good. It's not a parabola. Why is it not a parabola?
Because it has a non-parabolic
Has an
thing
odd
in it.
degree.
It's odd.
Yeah, the dominating degree is odd, so it's not even going to look like a parabola.
Oh.
Also, parabolas are squared powers.
Yeah.
Even x to the 4th looks like a parabola, but it's not actually a parabola, right? A parabola is just an x squared power.
Okay.
So you look at this guy, and you go, okay, that's going to be the big, like that's the big dog here, right? That's the thing that's going to dominate.
Yeah.
So if I go to positive infinity, if you plug in a really freaking giant number in here, you're going to get out a really giant negative number. You guys see that? So I'm going to get an arrow that goes down that way. You guys with me on that? Okay. When you plug in a really giant negative number over here,
Positive.
Positive.
so negative to the 5th is still going to be negative. Then you're going to multiply by a negative number.
Positive.
You're going to get a really big positive number. This is a thing with odd powers, right? Even powers are going to point either both up or both down. Odd powers are going to point one up, one down, or one down, then one up. I did those backwards, but
Doesn't
they're gonna
matter.
be
It's the same.
right. So then what can happen in the middle?
Anything?
It's gonna cross the y-axis.
It's definitely going to cross the x-axis. It's also definitely going to cross the y-axis.
Totally agree.
You guys see that?
Yeah.
It's definitely got to cross both axes to get from this quadrant to that one.
Yeah.
It might cross both axes at the same point.
Which is the origin.
It might go through 0, 0, right? This one specifically does not go through 0, 0. You guys all see that? This one specifically goes through 0, comma pi over e.
Polar coordinate.
You guys see that? So I know at least one point on this graph. It's right here. It's 0, comma pi over e.
Makes sense.
You guys see that? That might well be the only point on this graph you know. So then in between here, how many times can it cross the x-axis?
Once. Twice. Once.
3 times?
Three. What?
5.
Why 5?
Because the.
Yeah, because it's a 5th degree polynomial, right? So 2nd degree polynomials, parabolas can cross twice. 1st degree polynomials, lines, can cross once. So that seems like a theory. Let me just go with it.
So it'll cross 5 times.
We can prove that to you in calculus class, but I'm not going to prove it to you now. So x to the 5th can cross maybe 5 times. So if it did cross 5 times, it would go once, twice, 3, 4, 5. Right? So please note. What? Oh. Fair complaint. Good on you. Way to be, sir. So please note, this has some flat spots, right? You guys see these flat spots? Those are going to be something we chase after every day in calculus class. right? The maxes and mins, because those are going to be interesting things to us. So it's worth noting that fifth degree polynomial has at most 4 maxes. Well, really it doesn't have 4 maxes, right? It has 4 maxes or mins,
Yeah.
of which
2 are maximum.
2 are maxes and the other 2 are mins most of the time. There are ways to kind of dork this, right? Because you don't have to cross 5 times, you could cross just a couple.
So those ones wouldn't technically be the max and mins, they'd be the finite, like measurable max and mins?
Good. And these are what are called local maxes and mins because this has a
Supermax and Supermax.
minus, like a tendency towards minus infinity on one spot and a tendency towards plus infinity on another. So those are definitely not global values. You guys cool with this?
Yeah.
Questions on this kind of vaguish theory right now?
Wait, what happens though if it, like, say it's a fifth degree polynomial and it only crosses twice? Like,
Okay, so a fifth degree polynomial, right? So I know it's got a up and a down. I assumed negative here, but the other way is true too. So if it's going to cross twice, it'd go once, twice. Oh, but it needs to get back down there. You guys see that?
so is it,
So if it actually crosses twice, it would have to cross a third time.
Makes sense.
You guys see that?
It's like 1, 3, or 5.
Yeah, you cross out on amount of times.
Yeah. So it could tag and turn. You guys see that? Like the parabola that only touches once. So those rules are tough. But at most there are 5, which is pretty cut and dry. You guys see that? There's definitely 1 because it goes from up here to down there, and at worst there could be 5. Cool?
Yep.
Okay. Sweet.